we should create a plane for it to walk on. And with this kind of lighting, it's going to be, I don't know, a bit difficult to see our lightning. So why don't we make it significantly darker? I think I'll turn my sunlight to about 0.2. And then I'll create my own skybox. So create material, night sky. And we'll make it procedural, take the atmospheric thickness down, and make the ground just completely, almost completely black. Yeah? You guys haven't done that before?
No. What?
Skyboxes.
Okay.
Okay, so you're going to go to your assets folder and right click, create new material.
Right.
You're there, right?
Yeah.
Okay, so the next part is up here at the top, the shader. Change it from standard to skybox to procedural. Sorry. Oh, you guys didn't know about this?
No.
Man.
The only skybox we've ever done is like grab space, put space skybox preset thing from the website and stuff.
All right, so number one, just take this atmospheric thickness and make it, you know, so it's kind of golden in the viewport here. Can you do that? And then I want you to drag that into your scene, because I need you guys to see what's up. If you drag that into wherever the sky is, that new material, Game Design 2's first skybox. Wow. Okay, so if you look up at the sun, where is the sun?
My eyes.
Not anywhere? You see your sun? Okay, you can change the size of the sun with that slider there. That's a pretty cool look. I'm going to have to assign my sun source for the directional lights. Let's change this back to 1 for a second. Okay, there you go. That's very large. You can also turn the atmosphere thickness down by quite a bit. And if you haven't noticed that before in other with other skyboxes, you can rotate your sun, your directional light, to be in different spots around your level. And so that can be really nice when you're dealing with your procedural skybox. So, we're on Mars. We're on Jupiter. We're on the space station with no atmosphere. Okay, so the next thing to mess with is the colors of, for example, the sky tint. If you bring that saturation up and then start messing with it, you can get some nice pretty colors there. I believe that if you adjust the ground exposure, that can also affect things, but mostly what the ground exposure is going to do is affect the backlight or the ambient light of any objects in your scene. So you see how the underside of my cube is very blue? That's because the ground color is this bright blue that I made. So I changed that to green. So it does absolutely affect what your object's bounce color looks like, which is why it's good to keep it real low. And then what you'll see in your atmosphere color is going to be what's bounced, what the shadow colors are going to be, stuff like that. And then it gets real exciting as you bring up the atmosphere thickness. This blue turns into yellow, turns into green. See, aren't you glad you showed up the last day? Touch Best Skyboxes. It's awesome.
Or we found out eventually. A year or two from now.
Anyway, what I want for nighttime, directional light. Let's change your intensity down. The sun will actually be dimmer based on the what do you call it?
Directional light?
5, yeah, based on the intensity of your directional light. I want mine really dim so that it looks like nighttime. I also want these cubes to be very tall. They're going to be casting shadows from the lightning. So go ahead and make a few of those. The plane is 5 by 5, so that's 50 meters. Looks like these cubes are about 10 meters. And now that we have a bit of a level, would you go ahead and bring in an FPS controller? Get rid of that main camera that you've got. So my sky is still way too bright. But actually, I can bring my atmosphere thickness up, and that final slider, the exposure, can darken everything. So my exposure can be low, and my atmosphere can be, whatever crazy color I want. So that's nice.
Let's see. Zachary. Just forgot he was in this class.
He was, I think, maybe at the beginning of the semester.
Okay.
I'm not sure about that, but maybe.
Sweet. Sweet. So are you taking any time off on this Saturday? Or are you going to both deals?
I think I'm still only doing the morning.
Okay. Make sure you get a leave slip turned in for 2.5 hours.
I did.
For personal time. So got it, and it's approved, and it's done.
Yep.
Okay, that's all that matters.
The only error is I thought it was on the 13th, so it says the 13th, which means I need to go see Linda and say, hey, do you understand what I'm talking about? They probably do.
I'm sure they caught that.
Alrighty.
Thanks.
So I'm going to make sure you were turned in, that if you do it the day of, you don't get credit and you get written out.
Okay.
They started that a couple of years ago.
Okay.
So,
Thanks. All right, do we all have a dark area? Cody, make your exposure lower. Okay, so I may have gone a little bit interestingly, but that'll be fine. Okay, so here's what I want to do. Let's conceptualize first. Let's have a plan. Let's have nice color. Okay, so somewhere above this area, let's say right here, in an area around that, just anywhere, right above my plane, there's going to be a random spot. Maybe it's here, maybe it's here, maybe it's here, here, here. Okay? We're going to draw lightning, and it's going to go down, and then I'm going to pick a random spot around that smaller area to go left or right. And then again, actually I should just view this from the side, okay? This is a side view. It's going to be here. This is the point of origin, randomly picked. It's going to go down 1 meter and left or right, forward or back, one way or the other. And then different that time, and then different again, and then back here, and then back here. Every time going down in increments of, 1 meter. Okay? And we could probably randomize that downward area as well, but we do want to eventually get it to touch the bottom and then explode and, make thunder happen and lightning. So the idea is that it goes to this point, and then this point, and then this point, and then this point, and then hits the ground. So that's what's going to happen. Let's build an empty game object at the origin, which is 0, 0, 0. And we're going to add a component, lightning generator, a new script. Okay. Okay, so first things first, we want to make sure we can have this run. Just have it run. So first things first, let's have it print something to the console. So we need a timer. We need it to shoot lightning. I'm going to say at 4-second intervals. You can change that to 6 or 12 or whatever you want. I'm actually going to create an integer. Lightning interval equal to 4. This needs to be a float. I apologize.
You can zoom in just a little bit.
Yeah. Is that enough?
Yeah, that's good.
Okay. It might actually be easier if I was in a different color as well. Can you guys handle that? Okay. Jamie's just giving me crap. Okay, we also need a float timer equal to 0. This one should be public. Now we're going to create our timer. If timer is less than or equal to 0, actually no, if it's greater than. If it's greater than 0, subtract from timer. Timer minus equals time.delta time. Otherwise, create lightning. So go ahead and see if this works. Oh, I guess the other thing we need to do, this will run every frame unless we make timer equal to lightning interval. So that'll reset our timer so that it goes every 4 seconds. Get rid of that. Does it work? Anybody?
Mine says it.
Yours says it? Okay. So this is going to run at exactly 4 seconds. Every 4 seconds it'll run, and that's not how lightning usually works in the real world, is it? Let's go ahead and add a way to know how many seconds have elapsed since the last time. And then we're going to add time, or subtract time. So random.range is going to give us a number between -4 and +4. So it's possible that the timer will go off and then go off again, almost instantly. It's also possible that the timer will go off in 8 seconds, right? Because 4 + 4 is 8. That's the maximum. We could probably cut that in half if we wanted to change this number to, times 0.5. But I think I'm okay with 8 seconds between lightning and, almost no seconds between lightning. Is that okay with everyone else? Okay. Does everyone else understand that you can put all of this into their own parentheses? Oh, come on. There it is. And then times 0.5f. That's all you'd have to do to cut this in half. Don't write this, because that's not how I want to do it. It's how you want to do it. That's fine. You can do it. So let's go ahead and hit play, and we'll watch our console. Please don't maximize on play this time. So this goes off at 1.3, and then it goes off at 7 and 12, 15. Oh, there's 21.71, and then 21.75, and then again. Okay, cool. So lots of lightning and lots of variety. That's what I'm looking for. Why did I use... That's why. Okay, so let's talk about... let's talk about the line renderer. We're going to use something called a line renderer. I believe we can go to Game Objects, and then effects, and then line. And let's go ahead and set this to like 0 and -2 and 0. So it'll look like this. This line will always follow the camera, and it has a good amount of options in the inspector. Let's see, materials you might want to change. I was finding that when I used just like a particle, that the top and the bottom wasn't meeting the bottom of the ground, so I left it at default line. And this is an important one, positions and its size. So what I want you to do is I want you to change its size to 3. This first element 0 is the beginning of the line. The element 1 is the middle, and element 2 is the end. So if you change this to a y of -1, and this a y of -4, and this a y of -2, you'll actually see it changing as it goes, as we edit these values. So, all right, trying to get it so I can see both. So we could change the x to a 2 or a 3 or a 4. We can actually drag these one way or the other. Are you guys getting all these same effects?
Have you put the line under on?
Um,
Or is it just by itself?
It's on an empty game object, but you can also go to game object effects and then line.
Is it on the one, the game object that was made that has the
Let's
line?
leave it separate because we're going to instantiate it. All right. So that's an interesting one. The right now you have the ability to move it around with the position of the line. But if we were to check use world space, then no matter where we put the line, oh, actually we just can't move, just can't move it. Pivot. So we can move this around now, but the line will stay where it is. So that's good to know. And then we could turn loop on, but that doesn't make a lot of sense for the lightning that we're trying to make, so we're going to leave that off. We can adjust the width. We can actually, using this red line, adjust the width so that over time it gets smaller. That actually might look pretty nice. And then we can adjust the color over time. In my example, I was using a little bit of purple and a little bit of yellow. And that was pretty enjoyable. You also have the option of changing the number of corner vertices. If you drag that up, your lines will get more happy at the corners. You can see that there. And end cap vertices will round out those things as well. So I think for our lightning, we'll leave those at 0. But they can be useful to know about in the future. And then finally, this texture mode of stretch versus tile versus distribute per segment. This matters a lot when you have like an actual tile. I was messing with these snowflakes, and that was interesting, but as I moved these farther and farther apart, the texture like followed and stretched along the entire length. And so if we tile it, we get something like this, which isn't so bad. And then we get distribute per segment. So each segment just gets, the segment that it does. But as we increase the size to 5 or something like that, it stretches out. And that's not what I wanted. And then repeat per segment. Different and not what we want. So back to regular line for me. And there we go. So everyone go to Unity line renderer, and we'll go to the scripting API for the line renderer. And I want you to have a look at position count. So open that in a new tab. And I want you to have a look at set positions. Positions. Multiple positions. So in this first one, we have a reference to a line renderer named LR. We get the component line renderer. We don't have to set its material. We're fine with whatever the material currently is. And then we set some positions. So we create a new array of vector3 objects called positions, and we assign it to a new vector3 with 3, spaces. Position 0, new vector3. Positions 1, new vector3. Position 2, new vector3. And then we set the position count to the length of the positions we have. That was a terrible line, sorry. Which is 3. And then we do lr.setPositions, positions. Okay? So what we're going to build is a for loop that goes down 1 meter, or 2 meters, or such and such a amount of distance, and creates a new position every time it goes through the loop. And then at the end, once we have all those positions, we say, that's good, that's what I want. Position count and position length, set positions. Questions? No?
What'd you say you called it again? Because I'm not seeing the same code. You set positions.
So right now I'm looking at the position count. Good question. That's up at the top. So
Oh.
you see it? You're real close to it.
Good.
That's going okay.
So here's our code. So actually, let's talk about building our Lightning for the first time. Let's have a public int spawn range. And I'm going to go ahead and build this on a slider with range. And I'm going to have another public int for spawn height. And so this is how high up it's going to be. So after we have spawn range and spawn height, are we ready to move on? Okay. So we're going to create a new vector 3. Remember that a vector 3 is just x, y, and z. And so the first one is a random number between negative 25 and positive 25. That gives us a total of 50 meters. And then we're going to make sure that y is the spawn height. And then we'll do the same thing that we did for x for z. So that'll be where we start the lightning bolt. And let's go ahead and up above that, we're going to create our line renderer. We can name it LR. And you notice we don't have a bolt prefab. So we'll go ahead and build one of those. Public line renderer bolt prefab. And that'll let us drag and drop the one that we created under the level into that spot. Go ahead and tell me what you get once you're done with that. Always remembering to save.
Oh, jeez. Oh, you good?
Does anything crazy happen? Okay. Can you click on one of those clones? So this is in the exact same spot. In the exact same spot. So we haven't assigned any different positions yet. Right. Okay. Okay. So they're creating them, the clones, but they're creating them in the same exact spot. So we're not quite there yet. We haven't assigned any new positions yet.
Why is your update so
Oh, this button here. It's still there. Yeah, please don't delete that. I've had students be like, oh, he clearly deleted everything. Yeah, no, it's still there. You can, pro tip, if you ever have to present with someone, just get rid of that. You can do it for if statements, all sorts of stuff. Good question. Okay, let me make sure that my line renderer is in the right spot too. So there's my game object, which I'll rename Lightning Generator. And I'll name this Lightning Bolt, the Bolt Prefab. And then what I want next is a vector3 array. And we'll call this positions, just like the example. Equals new vector3 array, and we'll say, actually we're going to create a new vector. Now we'll just say 8 for now. That's fine. 8 breaks, 8 points is probably enough, isn't it? Hopefully you know how to create a for loop. That's going to be real important in the future. What's, yeah, no, no. So I'm going to redraw this for you. Make sure we know what's happening. Here's our for loop. Every time we want to go this way, or you know, back or forward, and we want to go down by 1 every time. So this is going to go down by, actually, well, 1/8 of the distance. See how we have 8 segments? We have 8 segments, so I want to go 1/8 of the way down from 75. So 75 divided by 8. That's not right. 75 times 0.125. Yeah, so I want to go that far down. And then I want to randomly go different directions on the x and the y, x and the z axis. So, path is a vector3 dot x is just a float. Random dot range. Let's say, what's that? Path.x?
You had your mouse over it, so it looked like a weird symbol.
Oh, okay. Path.x equals random.range. Let's say -4 to 4. I'm probably going to change these, but for now we're going to leave it as is so it's easy to understand. Y is equal to 75 divided by 8, yeah. And we can actually do spawn height divided by 8. And I'm just going to copy and paste and change it to z. So this will move that initial vector 3 that we created to somewhere else that is, lower down. And then just so that we know what's happening, I want to print this to the console. So print path. And if you remember how lists work or how arrays work, the position of I, first time 0, second time 1, this is just each number in the list. We have a list of vector 3s. They're all set to nothing right now. So the first position in the list is equal to path, the new one that we just made. This one's a bit interesting. The reason that I'm doing it this way instead of just doing position count and positions all at the end is because I don't know if you noticed my lightning, but you can watch it as it goes down. It doesn't all happen instantly. Did you notice that, Jamie? Yeah. So that was a cool effect. I was like, I can probably make that happen. So it's gonna draw that and update it every time through this for loop. And then we have finally lr.set positions with positions. If you would, please, tell me what this looks like. What are you getting? Some scribbles? Okay, so before you turn play off, select one of those clones and tell me what alphabet you're getting. Oh, I know what it is. I missed something. So it stays at 9 the whole time? The y value stays the same. I meant to put minus equals on path y. So I want it to go down. So that minus equals should help you out a lot. I'll be right there, Riley. Oh, sure. Okay. So right click on the asset folder, create a material. What's Skybox? Skybox is great too. We're going to drag that. Well, not there yet, actually. Inspector. We need to change the shaders now. Change Skybox and procedure. There we go. And now, changing it to sun size, the atmosphere thickness. The second step. Now, the weather report exposure is real low, so it looks very dark. Okay, now drag that to the just one just here. Yeah, on the skybox itself, right? So right there. And now you can edit that better, make it darker, change your directional light to a small number. Mine's like 22 on the intensity. Okay. So there's that. Does it go down now? Good. Why are yours all in the same spot? I mean, it looks cool.
Because it's a -4 forward on our range.
It is?
Or
But your first one.
at least I'm thinking that's what it is. Because they all
Oh. Is everyone's all in the same spot in the middle?
Yeah.
Okay. So we must be instantly changing the path to this. And what we want to do is we want to add -4 to +4 to wherever it currently is. So we don't want to. Yeah. So tell me what that one looks like. This right. That looks pretty good. Does it touch the ground? No. That's good because it didn't for me either, so I'm glad you guys are there. You guys like it? Okay. The line just goes beneath the planet for now, beneath the thing. So here's the rest of update for Dalton for a second. And that is honestly a great time for a break. We got some cool lightning. We got more to do, but let's take a break. Yep. If it's within a meter of the character, end the game, he just dies.
Or it knocks you off the map.
This
This is how lightning works, right?
You got it.
Perfect.
Excellent. Equals right here, instead of being equals, plus equals minus equals plus.
I know. Yeah, I just said.
And that's because I wrote it the wrong way first time.
Yes, got it.
Did anybody forget to sign in? Ricardo?
Yes.
Yeah.
While we're waiting, I'm just trying to trying to fix something on my file, so I can piece of it better on it. For some reason, the math mentions not working on these.
Don't turn play off.
Yeah. What's more?
He doesn't have anything talking right now. He doesn't have control.
I'm trying to script right here, but for some reason it won't let me apply to the object.
Oh, okay.
Yeah, we do.
Moves, so let's just try to look at it.
No, like, cause you just like.
I can't add script components.
Okay. That's pretty common because this name enemy movement doesn't match right there.
Oh, I need to. I just copy pasted this from the what was it? The Eagle console.
Sure. Looks like that should fix it. Which way you want to go? You let me know if you decide. Okay. So one of the things I'm really excited about, Adam, is that I figured out coroutines pretty well. As in, I used them how I expected to use them, and they worked the way I wanted them to work. This time, in this project specifically, so that's cool. Oh, I should stop recording.